Hi friends, in this class we will understand the solutions of two questions related to errors. First question says that in a resonance tube experiment, resonance occurs at two successive water levels of 30.7 cm and 63.2 cm with a tuning fork of 512 Hz. So first of all, we must understand that in between these two levels, half wave will be formed. A loop of this type will be formed, and this loop will represent half wave. So it means from this given data we can find out the half wavelength of sound as L2 minus L1. Also, we know that frequency and wavelength are related with the speed as v is equal to nu lambda, and frequency is given in the question. Lambda we can find out from the difference of these two, so this means lambda is equal to v upon nu. If we will put this value of lambda here, then we get v upon 2 nu is equal to L2 minus L1. The maximum possible error in calculating speed of sound is to be determined. We have obtained the relation between speed of sound and the water levels in the resonance tube, and these water levels L1 and L2 are given in the question. Frequency is also given in the question, so V must be equal to twice into frequency into L2 minus L1. What is asked here? The maximum possible error in calculating. Here frequency is given to us and we have measured only L1 and L2. So error in the measurement of speed will be only because of errors in the measurement of L1 and L2. So error in measurement of speed of sound. अब speed of sound में error चाहिए तो say this error is dB is equal to 2 constant, no error. New frequency is also given, so there will be no measurement of frequency, hence no error in frequency. There will be errors in L2 and L1, and here in the expression we are having difference of L2 and L1, and if we come to the errors, then for maximum possible errors, whether there is sum of the quantities or there is difference of the quantities, errors in them will get added. So it means maximum possible error in measurement of speed of sound will be 2 nu into error in measurement of L2 plus error in measurement of L1, and this implies dB is equal to 2 into frequency is 512 Hz and errors in measurement of L1 and L2 equal to least count of the measuring instrument, and from these values we are seeing that the least count of the measuring instrument is 0.1 centimeter because it is measuring up to only one place of decimal. So dL2 will be 0.1 plus 0.1 will be dL1, and this will give you 0.1, 0.1, 0.2 into 2, 0.4 into 512. 4 to the 8, 4 1 ja 4, 4 5 ja 20, 204.8 centimeter per second. It will be the maximum possible error in the measurement of speed of sound. Now we are taking one more example. In this example, if one takes into account finite mass of the proton, then correction to the binding energy of hydrogen atom is approximately, we have to find out what will be the correction to the binding energy of hydrogen atom. What is meant by this correction? It is equivalent to maximum possible error in the binding energy of hydrogen atom when there is an error in the measurement of mass. We know that mass and energy are related to each other by Einstein's mass energy relation. E is equal to mc square. This relation tells that energy and mass both are interconvertible. Mass can be converted into energy and energy can be converted into mass. Also, we must know that binding energy of hydrogen atom is also produced due to the mass defect. It means due to the mass lost during the formation of atom. So it means here E is equal to mc square tells that correction in energy will be due to correction in mass, and correction here is equivalent to error. So you may say that error in measurement of energy is due to error in measurement of mass, and this implies percentage correction in energy dE by E into 100 is equal to C is constant for all frames of reference. So it means C being constant, there will be no error in the measurement of C. So error will be only in the measurement of M. So dm upon M into 100, and from this we can find that dm, the maximum possible correction in the mass of proton. We know that during nuclear disintegrations, proton changes into neutron, neutron changes into proton, and maximum possible mass transferred between them is mass of electron. So it means maximum possible correction in the measurement of mass of proton is equal to mass of electron. So mass of electron is the maximum possible correction in the measurement of mass of proton, while m is the mass of proton multiplied by 100, and this will give you mass of electron from 9.1 into 10 to the power minus 31 divided by mass of proton 1.6 into 10 to the power minus 27 and multiplied by 100. This will give us 91 by 16 into 10 to the power minus 2, and 91 by 16, 6 is 96, so it will be approximately 6. So it will be approximately 6 into 10 to the power minus 2, that is 0.06%. In this way we can find out correction to the binding energy of hydrogen atom due to finite mass of proton.